Alright, hello everyone, that's Mr. Coach. I'm going to go over graph number 3. If you want to graph it on Desmos or something, you'll see what it looks like here. It's a graph that goes up, starts concave down, and then it does this turn right here, point of inflection, and it goes concave up for a while. And it does this turn right here and it goes concave back down. So this is a graph we're looking for. And we're going to get all of these parts from this. But always have your phone out to Desmos or have your calculator out to Desmos so that you can check everything you do. Alright, I'm just going to go quickly through it. I made this reference sheet. You can use all this reference sheet to help you with the different tests. Parent functions, any even will do. Y to anything, these are all even. And actually better than this, I really should have called them y equals negative x squared because it is reflected across the x-axis or y-axis going facing downward. So try and be more specific. It's a downward facing parabola. Intercept 0, 0, set it equal to 0 here, solve it, negative 4, 0. There is no symmetry. The test for symmetry is just to plug in negative x. And if you plug in negative x and you don't get the same thing, it's not even. And then what you can do next is factor out a negative 1 from here. And then if this is the same, then it's over the origin, and that's the test there. If it's exactly the same, it's even over the x-axis, over the y-axis here. And if it's negative, and the negative can be factored out to give you the same thing, then it's odd. That means it's over both axes, like this function. And this function is odd. This function is even. Even functions, odd functions. And the test is the same. Plug in this. Alright, domain. All numbers and the range. Range is kind of hard to do until you get the graph. And you can see this range goes from negative infinity up to 27 fourths. Continuity. Yes, it's continuous. There are no restrictions on these values here. In behavior, as x goes to infinity, x goes to negative infinity, just test this initial, or this function that's been simplified, and just test this. This will tell you everything you need to know. Plug in negative infinity, and you'd have negative infinity over 4. Well, that's going to go down. If you plug in negative infinity, you'll wind up at the same spot. There are no asymptotes. Asymptotes come from here, and for the slant asymptote, it needs to be a rational function. So we have no points where we have a discontinuity of 0, and the end behavior doesn't go to a number. The end behavior goes to infinity. Alright, you'll see the difference in the next one. First derivative test, critical points here. It's going up, down, down. Second derivative test, I like to put them right next to each other sometimes. And the relative max here, relative max is at negative 3, 27 fourths. And the global max, well, that's the global max here in concavity. Do the second derivative test, find your points, and if you overlap them, you'll see that it's going up, but then it starts to turn down, and at negative 2 is the shift in concavity right here. So we have the the intervals for concavity, points of inflection. Again, they're at negative 2 and 0 at both of these points, and you can see them on the graph. It is concave down, concave up, concave up, concave down. And that's what you're looking for right here. In red right here, I drew the concavity. Down, up, down. There's a point of inflection here. There's a point of inflection. And the thing to notice is it relates to this. There's a max here because it goes up, then down. There's a point of inflection here because it goes down, then up. Down, up, down. Inflection, inflection, max. Nothing going on here special. One thing I want to add to this, on these test points right here, let's start talking about what the meaning is behind these. When I say f of 2 is negative 12, that means it's below the axis. And take a look at this graph. If I come out to 2, it's definitely below the axis. And f prime of 2 is negative 20. Well, it's definitely decreasing. And f prime of 2 is negative 24, meaning concave down, and it's definitely concave down. So explain what these mean here. Alright, on the next graph, same deal, run through these tests. Well, what's the parent function? couple different options. A lot of people said it's 1 over x, which is a rational function. That's fine. Another way to look at it is this is y is equal to 2x over x, which is just y equals 2, and that's related to y equals 1, which was our parent function, but you can go ahead and write it like this. That's fine, because that's just a shift up of this parent function. So this, and here's the graph here, and you should see it has some of the tendencies of this graph, which look like that, and some of the tendencies of a line. If you zoom out, we have a line going here. We also have a line going here, but we have that form too. So parent functions, a few different options here. Intercepts, there they are. Symmetry, none. Again, you just plug in this, and after you plug in that, well, this is not exactly the same, so it's not even. And then what if I factor out a -1? Well, after I factor out a -1, this is still not even, so it's not over the origin. There is none. All right, domain and range. Domain can be everything but 3. Range, kind of tough. Wait till you're all done and you'll see that range can be everything but 2. You can figure it out up here, but sometimes it's easier to wait on the range. Continuity, well, of course not, because it's not in the domain. There's an infinite discontinuity at 3. How do I know it's an infinite discontinuity? Because it cannot be factored out. Holes in graphs can be factored out. Asymptotes cannot. All right, in behavior. As x goes here, let's just look at the most important part of the graph, y is equal to 2. So as we get closer to infinity, we get closer and closer to 2. Well, that's what makes this asymptote here, and you should see that in the picture. As we go out to infinity, it's going down to this asymptote. As I go to infinity this way, it's going up to that asymptote. So the graph is going to at infinity. Out here, it's going to 2. Horizontal asymptote comes from way up here. First derivative test. Well, go through the work. Intervals are here. 3 is the only one that matters. I took the derivative, and it's going down, then down. All right. Second derivative test, I put it right there. There are no relative extrema because it goes down, down. There are no global extrema because it goes down forever. Concavity, second derivative test. Point to check is 3. And look what I did here. The concavity is facing down, but the whole graph is going down, so I only want the right side of this concave graph, right? This concavity could be going up or down. I only want the down side. And over here on this concave up part, I could have this side or this side. I only want the down side, so it looks like that. And that shows you a great picture of what our graph looks like. Here's the down part, here's the down part, here's the down part, there's the down part. Points of inflection are where the concavity changes. Well, it goes from concave up to concave down, so you would think there would be a point of inflection right there. However, f of 3 is undefined, therefore there's no points of inflection. Right? To figure out this point, the point would be 3 something. To figure out what that is, that would be f of 3. Well, if I go back up here and I plug in 3, it's undefined, so it's not a point of inflection, and that's why it's not shown here. This, it goes down, then up, just like here, down and up come together. Here, down and up do not come together because it's undefined at 3. Test a random point. F prime of 2 is 0. That means it's on the axis. Good. F prime of -2 is -2. That means it's going down, and I drew that tangent right there. It's definitely going down. Down 2 over 1, down 2 over 1. And F double prime of 2 is -4, and it's definitely concave down there. Alright, last thing I want you to remember, I put this on here. PVA stands for position, velocity, acceleration. It is the F prime, F double prime. Position is points, velocity is change in position, which is direction, acceleration is change in velocity, which is concavity. They all follow one after each other. All right, hope this helps you prepare for the quiz.